Hey, welcome back, Math Gurus. Today's video will focus on adding and subtracting positive rational numbers fluently. Comes from TEK 5.3K. So in my class so far, we have added and subtracted positive decimals, which is a rational number. We've added and subtracted positive fractions, which is also rational numbers. When you get to junior high, it includes decimals, fractions, and then percent will introduced. All right, so let's read a couple of problems from an old STAR test. And it said 3 students each ran a part of the race. Okay, so we know we have 3 kids, 1, 2, and 3, and their total equaled 2 1/4. The first one ran 3/4 mile. The second one ran 65 hundredths, or 0.65, but we say 65 hundredths. And then the third one, we don't know, so I'll just use X as my variable that I don't know. You can leave it blank. X just means unknown. Maybe it'd be better if I just put a blank. All right, so if you notice the answer choices, they're all decimals. So what that's telling me is we have to convert all of these, which is nice because they're a benchmark fractions. So that's 75 hundredths. There's no decimal there. Plus something else is equal to 2 25 hundredths. All right, so what we're going to do is add the first and the second distance, and then we'll subtract it. Now, 1 40 hundredths or 1 4/10. It's all good, works the same way. We're going to subtract that from the total. We'll regroup. You end up with 85 hundredths. All right, let's look at another STAR release problem. It says the table shows how many miles Easton rode his bike last week. So 1/4 of a mile. Wednesday is 75 hundredths of a mile, and then Friday is 5/8 of a mile. How many total miles did he ride his bike last week? So in this, you can enter a decimal, you can enter a fraction. I'm going to go with fraction. As long as the answer is equivalent, the STAR will count it correct. So it's 1/4, and then 75 hundredths gets converted to 3/4, and then, plus 5/8 will give us our total. Well, we want common denominators, or your total group size needs to be the same. So I'm just going to show it how I've done it in my class. I tell my students we're finding equivalent fractions, also known as skip counting. So 1, 2, 3, 4. This is 4, 8, 12. I could keep going. I usually do 4 or 5. This one I'd skip count is 3, 6, 9, 12, 4, 8, 12, 16. So I'm skip counting. I'm just finding equivalent fractions. So just bear with me. All right, so here I times them both by 1, and then I times them by 2, times by 3, times by 3, times by 4, times by 4. That's all I did. We skip counted. I use the word skip count because that's what kids are familiar with. I'm looking at the bottom number, and I notice that 8 is the number that's the same as for all of them on the bottom, which is our denominator. So now we're going to add all of these. I'm going to go to the other side. You could probably hear my grandkids outside because that's why I'm kind of slowing down, because I'm hearing them at the same time. All right, we'll add all our numerators. You ended up with 7, because that's 5 plus 2 is 7, and you ended up with 13 eighths. You could put that in the answer for STAR and it would count it right. You could also simplify it. It's greater than 1 because the numerator is greater than 1. And so we actually can take out 1 whole, which is 8/8. My classes have talked about this in class. So it's 5/8. However, it's 1 and 5/8, or 13/8. If you put 13/8 together, you would be able to take out one whole, because 8 of them is one whole. So you could put this in your fraction, or you could just leave it 3/8. It's up to you. It'll work out. That's how you would put it in, or just use this and write 13. Well, you don't write, you would type it in. This is an old star problem. All right, well, thanks for watching. I hope this helped. Don't forget to hit like and subscribe.